Hello, welcome. My name is Mr. Fincher, and we're about to start a warm-up for today's lesson on sequences, just sequences. Go ahead and try it out. Pause your video. You have 3 questions. Take about 4 or 5 minutes to knock these guys out. All right, for number 1, we should have started at 1, plugging in 1. When you plug in 1, you get 3. Plug in 2, you get 5. Plug in 3, you get 7. And plug in 4, you get 9. When you add those up, you get 24. Way to go. Let's go ahead and look at number 2. You should have put n plus 3, then n plus 2, and then n plus 1, and that's where we match the denominator, so we can cancel those guys out. Let's use red. So my final answer is n squared. Ooh, I'm still in red. Didn't mean to be in red still. N squared plus 5 and plus 6 is what that multiplies out to be. For number 3, it says write an expression for the nth term. So we can see that we're multiplying by -2 every single time. So we could write this as, we're going from n equals, let's just do this, not with summation, because it doesn't say the series, just the nth term. So that would be 2 times -2 to the n minus 1, it looks like. I think that would work. Another way that you could have written that is, let's see. Negative, -1, -2 to the n, I think would work. Maybe. Yeah, it does. So if you plug in 1, you're going to get the +2 that you want. 2 options. Have fun. All right, for today, our 2 objectives are to define equations for arithmetic and geometric sequences. Everyone say arithmetic. Good work. Arithmetic is the way to say it. It's not arithmetic. It's arithmetic. I'm not sure why. I want to say that it's an adjective instead of a noun. Noun is the subject that your great-grandparents took in class, in school. All right, and then we're also going to evaluate arithmetic and geometric sequences. An arithmetic sequence is a sequence with a common difference. Pretty straightforward. You are adding something every time. Could be something small, could be something big, could be something negative, could be something that's a fraction or a decimal. So for the first one, we have 3, 5, 7, 9, 11. We are adding what? We're adding 2. I was about to say 3. That's wrong. Plus 2 here, plus 2 here, plus 2 here. And we can do a lot of stuff with that. All right, understanding that we are adding. So we need to recognize that something over here is also an addition. Figure out what that is. It is a plus 2.5. 2.5. We have an addition of all those beautiful things. Now, there are 2 ways to write arithmetic sequences. One is recursive rule. Everybody say recursive. Recursive. Good work. It tells you the next term of a sequence. So it basically builds on itself. You have 2 pieces, actually 3 that you need to build. You need to be given the first term, because you can't tell me the next term until you know what the first term is. And then you're just going to add D, which is known as your common difference. This is your common difference. We use common difference because difference starts with a D. I guess. I think so. Okay, so basically the term before, and this would be the next term. So the only way to determine the next term is to know what happened before it. And that's how the recursive rule works for arithmetic. Let's try this out. So let's find the next 4 terms and the 8th term of the recursively defined sequence. We're not going to give you this box like you see, this table, but I'm going to go ahead and help us out by putting the first 3 terms, the next 4 terms, so 2, 3, 4, and then 5. And then it also says for you to find the 8th term. So let's try it out. This says our first term is 8. Great. They gave it to us. Then it says that we take our previous term, we do what to it? We subtract 4 to get our next term. So we really don't, we just can have that in our brain and we can think through how that would work. For 8, if we subtract 4, we get 4. 4, we subtract 4, we get 0. 0, we subtract 4, we get negative 4. Negative 4, we subtract 4, and we get negative 8. For n equals 8, that's a few more times, so let's think of what would happen. So let's do a little. 6 would be negative 12. 7 would be negative 16. And then 8 would be negative 20. Are we all okay on that? All right. Well, good. Let's go ahead and take a little bit of time to talk about this guy over here, because that's a little different. There are restrictions given for recursive values, basically saying, hey, n can't be negative or 0. So the first n that we are given is 2, because we know what a sub 1 is. So they don't want you to plug in a value that's incorrect as you work. As long as you remember this is your previous, this is your next, and follow what it says, subtracting 4. All right, the next one says to, this is not arithmetic, but we're going to treat it kind of like we did before. Let's take a look. We're given the first two terms, negative 2 and 3. Great, great. And this one says that I take my, I know this is my previous. What is this? It's the previous of the previous. So like 2 before. So if I take my 2 before and my previous and I add them, I will get my term next. So that's why, I guess that's why they gave us the first two terms, because you got to know those to add them together. So I'm going to go ahead and write n equals 3, n equals 4, n equals 5, n equals 6, and then it says for us to find n equals 8. So for our first term, if we add 2 and 3 together, we get 5. If we add 3 and 5 together, we get 8. If we add 5 and 8 together, we get 13. And if we add 8 and 13 together, we get 21. Let's go ahead and add the previous two terms again to get the seventh term. That would be 34. And then if we add these two together, we get 55. I do believe is correct. Yes, 55. That's not a 5. That's a 5. For this one, it restricted us to n being greater than or equal to 3. That's because they already gave us 1 and 2, and they had to in order for us to find the third. There is a really cool Fibonacci sequence that you may have heard before. Fibonacci came up with a sequence that looks like this. Which is similar to what we are seeing here. And what it is it is the addition of the two previous terms. And that has a lot of really cool application, especially like in accordance with the golden ratio and some things like that. But it's just, there's a lot of stuff involving the Fibonacci. I think that's how you spell it. I could be wrong, but it's the Fibonacci sequence. Look it up. It's pretty amazing. It's got some cool graphics too. All right, find the next 5 terms. Well, I'm going to let you do that. Pause your video. Try these 3. All right, next 5 terms. You're given the first term, which is negative 2. So the next 5 terms would be 1, 4, 7, 10, and 13. For the next one, this is actually not arithmetic because you're adding different values, but you're given that the first term is 2, the second term is 0. So if we add those up, we get 2. Add those up, we get 2. Add those up, we get 4. Add those up, we get 6. And add those up when we get 10. For the very last one, you're given, different stuff, different. But this is the same idea. If this is what we're finding at the next term, this would be the previous, and this would be 2 before. They just decided to mess with you, right? Well, this would be negative 4, 1, negative 3, negative 2,